Here's the last day of notes for this unit of PreCal senior spring semester. So this last thing what we're going to do is called a hyperbola. So hyperbolas are these two kind of parabola looking things all in the same graph, and they have something that looks like this. Now, more challenging hyperbolas is where they have an h and k as center. But in this class, we try to keep it simple and straightforward, where these hyperbolas will always be centered at 0, 0. And we have all this information. So we are going to have focal points like what we have been doing, but this equation is a little different compared to ellipses. So notice with hyperbolas, this is subtracting. Now this is adding. So they kind of do the opposite. So ellipses, they first started with adding, and then you subtracted a squared and b squared. So that's an easy way to kind of tell, like, or remember, like, which equation goes with which. All right. So how do we get hyperbolas from conics? Well, if you have two conics that are kind of at the tip of each other that look like this, and you draw a plane that is directly perpendicular to the bases of those cones, you have these things called hyperbolas. And notice that there's two of them. So let's just go and do this. So in this first question here, we have x squared minus over 25 minus y squared over 36 equals to 1. So the center, again, in this class will always be 0, 0. We know that this is a hyperbola because this is subtracting. So it doesn't matter which one a squared or b squared is. It doesn't matter if it's bigger or smaller. But 25 is underneath x squared. So that means I'm going to go left and right 5 from the center. So there. Then I'm going to go up and down 6 because 36 is underneath y squared. You square root, you get 6. So 1, 2, 3, 4, 5, 6. So what I'm going to do is I'm going to kind of dash in this box kind of thing. Because what this is going to allow me to do is if I draw a line from corner to corner, this is what's going to create these things called asymptotes. So I'm going to have those, and I'm going to have this one. So there's going to be two of them that go from each of the corners of that box. So those asymptotes are going to be very important because that's where the hyperbola is going to get closer and closer to. So since we had x squared minus y squared, this is going to create a hyperbola that's opening to the left and to the right. So my hyperbolas are going to be here and here. So those 2 points are going to be my vertices. It's going to be at 5, 0 and negative 5, 0. Or I can write it as 1 as plus or minus 5, 0. Now, part B is asking, are those x-intercepts or y-intercepts? Well, those were x-intercepts because x started the hyperbola equation, so we got that. Our focal points are going to use this equation that's different than what we had with ellipses, c squared. I'm going to change my pen width here. So c squared is actually going to equal to a squared plus b squared, which it doesn't matter what order we do that in. So 25 plus 36, and you end up getting c squared equals 61. So c equals the square root of 61, and it can't be reduced. So, well, 61 is between 49 and 64, so that means our focal point somewhere between 7 and 8. So 5, 6, 7, 8, so somewhere here. 5, 6, 7, 8, so somewhere here. Those are my focal points. So what I can do is for my foci here, I can just do plus or minus the square root of 61, 0, because those foci ordered pairs should be the same, like should have something very similar to vertices. Now, what were the equation of those asymptotes? Well, the y-intercept starts at 0. We went up 6 and to the right 5. So we rose 6 and ran 5. But if I go over here, I went down 6 and to the right 5. So what I would get for my asymptotes would just be y equals plus or minus, well, 6/5 x. And that's it. So again, just like all the rest of the conics that we've been doing, we're kind of just getting a lot of the information from the graphs after graphing them. So what's different about this one? Well, y squared is first, then minus x squared. So that's going to change where our hyperbolas are. So since 16 is underneath y squared, I'm going to go up and down 4. B squared of 16 is 4. 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to go left and right 6. And then I'm going to do the best I can to draw this box. I like dashing it in. That box is not actual part of my hyperbola. What it does is that it helps me create this line that goes through each of the corners of this box. If I was doing this on paper, I'd probably just get a ruler and go through those corners, and it would help me create these asymptotes. And I like to dash in my asymptotes, so I'm going to change those to dashed. Now, since our fraction had y squared first, what I'm going to do is I'm going to have my hyperbola open up and down. So I'm going to have a piece that looks like this, and a piece that looks like this, and this is again because it's y squared first. So our vertices ended up being at 0 and positive -4. Since y squared showed up there first, these are my y-intercepts. My foci is using that new equation, c squared equals a squared plus b squared. Our denominators are 16 and 36. So if you add those up, you end up getting 52, which if you square root, you can actually simplify. Base 52 is 4 times 13. So you get 2 root 13. So our focal points are going to be at 0 and plus or minus 2 root 13. Well, 52 is between 49 and 64. So this focal point is going to be somewhere between 7 and 8. So 1, 2, 3, 4, 5, 6, 7. Somewhere here. 4, 5, 6, 7. Right. 1, 2, 3, 4, 5, 6, 7. So somewhere there. So those are my focal points. And again, if I wanted to find the slope of these, we go rise 1, 2, 3, 4, over run 1, 2, 3, 4, 5, 6. But I don't want to write a slope of 4, 6. It should be simplified. So we're going to do y equals plus or minus, not 4, 6, but that reduces to 2/3 x. So remember that there are two asymptotes here. They both have the exact same slope, just one's negative and one's positive. So make sure that pretty much it's the exact same equation, y equals plus or minus, put the slope and x. Now you might be wondering, okay, well, how do we complete the square with these? We don't. What's nice about these is all I need to do is make sure my variables are on the same side. So I'm going to subtract 3 on both sides. And I'm going to divide everything by 12 because it needs to equal 1. So we end up getting y squared over 1 minus x squared over 4 equals 1. Because again, with hyperbolas, that has to equal to 1. So since y squared has 1 underneath it, we're going to square root 1 and get 1. So we're going to go up and down 1. There was a 4 underneath the x squared, so we're going to square root that and get 2. So we're going to go left and right 2. So our box here is going to be a little tiny, but our asymptotes are still going to go through those corners. Probably need to figure out how to draw these lines a little bit better so that it doesn't change the other corner. Let's see how well I can do this line. Still about the same. Okay, it's close enough. All right, so I like seeing those dashed. I don't know what happened here. And if we go back to our equation, we had y squared that showed up first, so that means our hyperbola opens up and down. So these asymptotes are helpful because that is where your hyperbola should be going out towards. Their asymptotes, it's kind of attracting the graph, but usually not crossing them. I kind of went over that asymptote a little bit. So since y squared showed up first, our vertices are up and down. So those points were at positive and negative 1. These are y-intercepts. Our foci, again, we have that equation where c squared equals a squared plus b squared. So 1 plus 4. So c squared equals 5. So c is the square root of 5. So that means our focal points are going to be 5 is between 4 and 9. So between 2 and 3. So 1, 2, some change. 1, 2, and some change. Those are my focal points. Those points have a x value of 0. And then we went up and down root 5. The equation of the asymptotes, our rise was up 1 and we ran 2. So our slope is a half. So y equals plus or minus 1/2 x. All right, and then this last problem here, the variables are on the same side. We just need to get this equal to 1, so we're going to divide everything by 16. So we end up getting x squared over 4 minus y squared over 16 equals to 1. So 400 is underneath the x squared, so we're going to go left and right 2, because you square root 4, you get 2. 16 is underneath y squared, so we're going to go up and down 4, because square root of 16 is 4. That helps us create this box. Which allows me, so helps me to graph these asymptotes. Well, that first one was pretty good, and then that second one kind of messed up. Oh, whoa, I don't know what's happening with my lines here. Might be my pencil or my iPad. And then I'll kind of make these look dashed. All right. So since our equation starts off with x squared, our hyperbola is going to open left and right. So I'm going to go this way, and that way, and then this way. Oop, that's too much. That way, and that way. So our vertices end up being at plus or minus 2, 0. These are x-intercepts. The focal point happens because c squared is equal to a squared, which is 4, or 16, doesn't matter. We add 4 and 16, get 20. If you square root both sides and simplify it, you end up getting 2 root 5. So 20 is between 16 and 25, somewhere between 4 and 5 from the center. So 0, or 1, 2, 3, 4 here. 1, 2, 3, 4, somewhere here. Those are my focal points. So those ended up being at plus or minus 2 root 5, 0. And our asymptote, we went from the center, our slope is 1, 2, 3, 4, and then to the run 2. So 4 over 2, which reduces to just 2. So y equals plus or minus 2x, or the equation of my asymptotes. So those are just the very basics of hyperbolas. In this class, we try to keep it a little simple. So just make sure you practice these and ask questions.